Hello students, today I'm going to discuss with you IGCSE chemistry past paper. It is paper 4 theory extended 1 May-June 2018. Okay, so let's get started. Question number 1. Give the name of the process that is used. A. To obtain water from the aqueous sodium chloride. So first question, it is given about the process to be written. Clear? So you can just have an answer with these questions. That what is the name of the process that is used to obtain water from the aqueous sodium chloride, I mean from salt water. Okay, so basically we use simple distillation. So we cannot write here fractional distillation. Why? Because fractional distillation basically we meant for when there is a similar boiling points. Okay, but simple distillation we can use where there is a large difference between that. Okay, so answer will be simple distillation. Next, it's B. What is the name of the process to produce lead from molten lead bromide? Okay, generally we tend to get metals from the metal related compounds. Like here we have asked to write how we're going to produce lead metal from the lead bromide, so by means of electrolysis. Clear? Now see, what is the name of the process to separate an insoluble solid from a liquid? Just you need to write a one word answers, the process only to be written over here in these questions. So how are you going to separate the insoluble solid from the liquid? Basically by means of filtration process. So answer going to be the filtration. Okay, now the next one is D. What is the name of the process to separate the component of petroleum? So it is well known to you that you're going to separate the petroleum product by the help of fractional distillations, right? So just you have to write here fractional distillation. Okay, E. Name of the process to separate a mixture of colored dyes. So in fact, you know that the colored mixture to be separated by the help of the technique called chromatography. Okay, so chromatography, it's a process to separate out the colored mixtures. So here you can write chromatography process. Okay, so let me move on to the next question, question number 2. So here you could see this question is about the element in period 3 of the periodic table. So we know that modern periodic tables, you know how many total element present in the modern periodic classification. So there's all totals as of now, there will be 118. So, and this modern periodic classification have been made based on the increasing order of atomic number. Okay, but here we are not going to discuss about that. Just here look at it. They have given one period. Okay, so you know that modern periodic tables has been classified in terms of groups and periods. How many groups and how many periods? Do you know? Absolutely. So the period numbers could be 7. Okay, whereas the group will be 18. So it is the third period. Third period elements are actually sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and the last one is argon. Okay, this is the third period element is given. Now, each of the following identify a period 3 element which matches the description. Each element may be used once, more than once, or not at all. State which period 3 elements. Okay, first one here, the questions A. Which element form an oxide of macromolecular structure? So if you look at the period 3 elements in the modern periodic tables, you're going to get here the element which tends to form the macromolecular structure. Macromolecular structure means large. Okay, macromolecular structure means huge structure. Basically, the element called silicon will make macromolecular structures. Okay, which one? By means of silicon dioxide. Like silicon dioxide has a huge structure. Okay, now next one, B. Which element is extracted from the ore bauxite? So we know that aluminum gonna extract from the bauxite because the formula of bauxite is actually Al2O3, right? So Al2O3, how? By means of electrolysis process you can extract aluminum. Okay, so aluminum can be extracted from aluminum oxide. So aluminum oxide name is called bauxite. Is it clear? So just write here aluminum. Next, see which element is soft, metallic, and stored in oil. So look at in this period 3, whether it is sodium or magnesium, aluminum, there are 3 elements in sequence. Okay, so we know that the first group element gonna be the soft element, and moreover very reactive elements, right? So they are talking about in the questions, it must be a soft and metallic, and that has to be stored in oil. So as in fact we know the first group element, I mean here we could see sodium is there, right? So it's going to be very reactive, so we tend to store under the oil, understand? And moreover it's a soft, and of course it is a metallic in nature, so that is why you can write here sodium. Okay, now let me come to D. So which element is a green gas at room temperature and pressure? It is well known to you that it's going to be chlorine. So chlorine is there, so here just write it, chlorine. Okay, so next question is number 3. Number 3 says about complete the following table. Okay, so here in the table, it is already mentioned particles, sodium, chlorine, ions, okay, and there were the box given that have to be filled with the answers. Already I have written the answer in earlier, okay, that it will be easy for you, that I'm not going to spend a lot of times. And moreover, you know, this, if at all I write here itself by typing some, you know, question answers, so that's going to take long time, and the video going to be a very long in length. Okay, so that is why just in before it's I have written here. Okay, fine. So particle is there, and in this box is meant for number of protons and the number of electrons. Okay, clear? So here you can say number of neutrons also. Okay, and number of nucleon also there. Okay, so we have to fill the blanks. Now look at particles. First one, sodium. Okay, here atomic number 11, and you know the nuclear number is 23. So already they mentioned the proton number 11, the number of electron also the same as it is, like 11, and number of neutron to be written. So number of neutron, how you going to find it? So basically by means of this formula you will be finding the number of neutrons. So number of neutron to be calculated, but just by subtracting from a nuclear number minus a proton number. So here A meant for nuclear number, what is found just at the head of this element, I mean the top of the element, and Z is meant for proton number, which you can find just at bottom of this element. Okay, so in fact what do you do here? We have nuclear number is 23 already mentioned here. So 23 minus 11, so you're gonna get it 12. So 12 we just write here number of neutrons. Next particle is chlorine, negative is mentioned. Okay, their proton number is 17 and the nuclear number is 37 in this particles. So we have to write it. What is the number of proton? So already it is clearly mentioned the 17 is going to be the proton number. Okay, just write 17. And you know that if the proton number will be 17, then electron also will be the same, supposed to be the same, right? 17. But here chlorine minus is there. That means chlorine has gained one extra electron. So before it was 17, now after gaining one electron, it's going to be 18. Okay, before it was 17, after gaining one electron, it became 18. So that means here you have to write for chlorine minus one ions, because it is not an atom, it is an ion. So the electron number will be 8. Okay, then you have to write a nuclear number. So what is the nuclear? It is the nuclear number. So it is clearly mentioned here, right? It is clearly mentioned in this case. So it's going to be 37. Am I right? 37. So that you can write here just simply 37. But last one is particles did not give you, but you know the proton number, electron number, neutron number, and the nuclear number is provided in this box. So you're gonna write the element name, I mean the particle name. Okay, so here in fact, whenever you have not given the element name but the proton number and the rest of the subatomic there, I mean electrons and neutrons and nucleons, all of them have given, then just remember that you're gonna see the proton number first. Okay, proton numbers are always fixed, but electron number can vary based on the receiving or donating in terms of ions. Okay, so look at the proton number, how much? 26. That means it's going to be the ion, because here also you mentioned here 26 and the nuclear number is 56, right? So but look at it, the number of electron case is 24. It's supposed to be 26 because we know that each atom has same number of protons and electrons, so that it can be considered to be like a neutron in state, right? So here if proton number is 26, then the electron number also supposed to be 26, but here already given 24. 24 means 2 electron has been lost. That means here the atom is not going to be the single in state. It's supposed to be an ion. Okay, it's supposed to be a ion. Okay, so which ion? The metal ion. Here we have like a ion 2 plus. So that ion has lost 2 electrons. So that electron number is 24 and remaining there as it is. Okay, in this way you can fill. Now come to fourth one. Potassium react with bromine at room temperature to form potassium bromide. This is potassium bromide to be made. A, write a chemical equation for this reaction, includes state symbol. So it's going to be 3-mark questions. Okay, for writing proper chemical reaction, 1 mark. For balancing chemical equation, another marks. And finally, for writing state symbol, you will be given 1 mark. So all total will be 3 marks. So what is state symbol? State symbol means how it seems to be physically. It can be solid or liquid or gas. Okay, that going to be the state symbol. So here we know potassium react with bromine to produce potassium bromide. So we know that potassium is a metal. It is found in the solid state. So write small s under the bracket. So that's going to be the state symbol for potassium. Similarly, bromine is a liquid state, so write small l. Okay, the state symbol always written in the form of small letter of English alphabet. Okay, if it is gas, then you have to just write small c. So here bromine is a liquid, so write L under the bracket. So then finally the product will be potassium bromide. It is also the solid state. Well, so the next is B. Potassium bromide exists as an ionic lattice. Potassium bromide does not conduct electricity when solid, but does conduct electricity when molten. First bit says, what is meant by the term ionic lattice? So from this word itself, we can define ionic is basically positive and negative charge. Lattice means arrangement, regular arrangement. Lattice means what? Pattern or arrangement. So basically, this is known as what ionic lattice means. So ionic lattice means a regular arrangement of positive and negative ion. So is known as ionic lattice. Clear? So now second one, explain why potassium bromide does not conduct electricity when solid but does conduct electricity when molten. So it is very easy question for you, right? So potassium bromide does not conduct electricity when it is in the solid state, whereas it does conduct electricity when molten. Okay, molten is semi-liquid form. Okay, so just I like to express these answers in few words. So remember one thing. In fact, in solid state, the ions are not ready to move or ions are not available to move. Okay, because when there is a movement of ions, so we're gonna say that it is actually like a flow of current, you can say, or there is a electric current. But if at all the ions are not moving at all, so you cannot say that there will be a conductivity, right? There will be the transfer of electricity or current, something like that. So the simple answer you write, potassium bromide does not conduct electricity in solid because ions are not free to move, whereas the ions are free to move in case of molten state. In the liquid state, ions are easy or movable and they are free to move. Now see, concentrated aqueous potassium bromide is an electrolyte. What is meant by the term electrolyte? It's very simple. In the electrolysis chapter we have discussed, right? So electrolyte basically it's a substance that conduct electricity in the electrolysis process, right? Or in other word, you can write it's aqueous solutions or liquids allow the ion to pass through it. That also can be appreciated well. Okay, next. Describe the electrolysis of concentrated aqueous potassium bromide. Include the ionic half equation for the reaction at the cathode. Second one, name of the product at the anode. And the third one is the name of the potassium compound form. Okay, three things have to be mentioned here. First one is what is the ionic half equation. Secondly, what could be the product at anode. And thirdly, what is the compound to be produced or made in these chemical reactions. Okay, so first and foremost, what you're gonna do is here, as they mentioned about concentrated aqueous potassium bromide. Okay, in this case, you will be having water. Okay, but water concentration is very less over here. So water, when it is provided electric current, so it's gonna split into H plus ion and OH minus ion. And potassium bromide, it will be producing K plus ion and Br minus ion. So there's gonna be a 4 different type of ion present. So 2 cation, 2 anion. So cation, which one? Hydrogen plus and potassium plus. Whereas anions are actually hydroxide, OH minus and Br minus. You know that in the electrolysis process there will be 2 electrodes. So just here for diagram, here we have a anode and this side actually cathode. So anode is meant for positive charge. Okay, cathode is actually basically negative charge. So we know that at the cathode or anode only a ion can discharge which is less reactive. Okay, in the reactivity series, it can be a positive charged ion or negative charged ion. Basically positive charged ion, okay, that's gonna discharge or that can be deposited at the cathode because positive charge attracted towards negative cathode. Okay, and the negative ions, what we call here anions are hydroxide and bromide, that's discharge at the anode, positive anode. Okay, so here in fact there are 4 different type of ions are there, 4 different type of ions in terms of H plus, K plus, OH minus, Br minus, but 2 only supposed to be discharged into respective electrodes. So for that we need to have a selective ion. We need to have out of in between hydrogen plus and K plus, we should have only 1 ions. because anode cathode they accept only one and one. Okay, anode accept one negatively ion, cathode accept one positively ion. So but here we have four, so that is why selective ion to be taken. So how it's going to be selected out of this four? So we need to have a electro, chemical series. So metal reactivity series, hydrogen and potassium, the position, which is more reactive. So more reactive is going to be potassium. So always remember in the electrolysis, less reactive metal ions going to be discharged because it is like a ease discharge of metal ion in the cathode taken place. Okay, so here in between hydrogen plus and potassium, which is less reactive in the metal reactivity series? Obviously hydrogen. So hydrogen gas, discharge after gaining electrons. So here a reduction reaction takes place. Where? At the cathode. Reduction means gain of electron. So you can write hydrogen gain 2 electron to produce hydrogen gas. Okay. On the other hand, we have two ions. Which one? Hydroxide also and Br minus. Only one supposed to be discharged at the anode. So which will be discharged here? Bromide or hydroxide? So obviously we know that in the anion reactivity series, hydroxide is the less reactive. Hydroxide supposed to discharge. But here what happens, as it is mentioned, concentrated. So here the concentration of bromine will be more. So that instead of hydroxide ion, bromine gonna be discharged over here at anode electrode, so that bromine gas will be produced. So you can say the cathode ionic half equation is this, and the product of anode is going to the bromine liquid. Okay, it is, and then hydroxide, and the remaining part is actually potassium and hydroxide ion. It is there still in the solution, so they're gonna form potassium hydroxide. So these are the three answers for these questions. Okay, in this way you can answer. Understand? Is it clear? Okay, third one. When molten potassium bromide is electrolyzed, the product at the cathode is different. Name of the product at the cathode when molten potassium bromide is electrolyzed. It is very simple. Okay, when there will be just a dilute form of compounds or concentrated, by the time you will think about the water. Okay, but when there will be questions related to the molten state. Okay, molten state. So just remember there will be absence of water in the molten state. Clear? So here they are mentioned about potassium bromide, molten potassium bromide. That means here only KBr is there. There will be no water. So that when the potassium bromide will be provided electricity, so it will be divided into K plus and Br minus. The K plus means potassium plus, it will be discharged at the cathode. Okay, and bromide ion will be discharged at the anode to form bromine liquid. So the product will be potassium metal, and that will be at the cathode, whereas the bromine liquid will be produced at the anode. So that's going to be the Br2. Okay, very good. The next one is the iodine react with the chlorine to form iodine monochloride, ICl, as only the product. First bit, write chemical equation for the reaction is very simple. Iodine plus chlorine gives rise to iodine chloride. Just balance the chemical equation. So how are you going to balance it? Just look at it. The number of atoms present at the reactant side and the product side is that's equal, then that is a balanced chemical equations. If it is not balanced, just you have to multiply the number in front of the element so that it's going to be balanced. Okay. Next one, bit 2. Draw a dot and cross diagram to show the electron arrangement in the molecules of iodine monochloride. So the outer shell electrons. So in fact, this iodine and chlorine, this is going to be the 7th A group element. These are seventh A group element. So why it is called seventh A group element? Because in the outer shell, they will be having always 7 electrons. Okay, so 7 electrons will be present in the outer shell of halogen element in terms of iodine and chlorine. So for example, here we have chlorine atomic number is 17. So electronic configuration is 2, 8, 7. That means 7 electron is the outermost shell. So you have to show the outer shell electron only. Okay. So all the halogen element will have 7 electrons in their outer shell. Basically, you have to take the outer shell electron only. So here the dot and cross diagrams you have to do for iodine and chlorine. So just write here iodine and iodine and arrange the electron. How many? 7 electron here. Like let's say it is a dot. Okay, here 1, here 1, 2, 3, 4, 5, 6, and here 7. Okay, 7 electron you have to. For another, for chlorine atom also you have to take 7 electrons because both of them are basically from the halogen element, right? 7, group 7 the element. So this cross is actually electron of chlorine. 1, 2, okay, 3, 4, 5, 6, and here 1, 7. So that now look at it. They share one pair of electrons, right? So if you talk about iodine, so iodine fulfilled with 8 electrons. So iodine satisfy octet rules, whereas chlorine also satisfied octet 1, 2, 3, 4, 5, 6, 7, 8. Iodine also 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be the dot and cross diagram. Okay, so basically when you ask to write dot and cross diagram, so you'll be given a compound. So look at it. The electron of first element you take in the form of a dot, it's fine, and the next element will cross. Then how many electrons is required to be shared? So each of them needs 1 electron, so that one pair of electron will be being shared. And as both of them are non-metal, so this is called mutual sharing of electrons, covalent bond. Okay. Now E. Potassium bromide has a melting point of 734 degrees centigrade. Iodine monochloride has melting point of 27 degrees centigrade. Okay. So in terms of attractive forces, explain why there is a large difference between the melting points. Okay. So how you going to write the answers? What is the answers supposed to be written for these questions? So it is already mentioned that the melting points, there will be large difference, large gap of the melting point, right? We know, in fact, potassium bromide is an ionic compound, right? Potassium is a metal, bromine is a non-metal. So when there is a transfer of electrons, the ionic bond to be formed. So ionic bonds are really strong bond, and there will be strong attractive force, electrostatic forces present. Whereas iodine chloride is a covalent compound, right? Iodine is a non-metal and chlorine also non-metal. So when there is a mutual sharing of electron in between two non-metals, so which bond to be formed? Covalent bond. So covalent bond has van der Waals force. So van der Waals force is actually weak force of attraction. So you just simply write here. KBr is any compound has strong attractive force, where the iodine monochloride, so covalent compound, has less attractive force, less attractive intermolecular force of attraction. Also we can mention that. Okay, but because potassium bromide is ionic, so it's required more energy to break the bond, whereas the iodine monochloride required less energy to break the bond. Okay, this simple answer you just write. Now let me move on to the next one. F. When chlorine gas is passed through the aqueous potassium bromide, a redox reaction occurs. The ionic equation is shown. So can you see this is the equations? Okay. So chlorine react with bromide ion to produce chlorine ion and then bromine. First, we tried an equation showing what happened to the chlorine molecule Cl2 in this reaction. So what happened to Cl2? The Cl2 gain electron to form Cl minus 1, understand? Whereas Br minus ion lost electron to became Br2. So what happened to chlorine here? Chlorine actually gained electron. So we know that in terms of electron, you can define the oxidation or reduction reaction rate. So gain of electron is known as reduction. That means chlorine reduced. So in fact, here you just need to know that which is reduced, that is said to be oxidizing agent. Remember it. And on the other hand, bromine, what we called it Br minus as well. That's actually lost electrons. So loss of electron is known as oxidation. Oxidation means it bromide is actually oxidized. So which is oxidized, that is known as reducing agent. Reducing agent. So you simply write here chlorine gain electron to form chlorine minus. Okay, and then second one is explain why the bromide ion Br minus act as a reducing agent in this reaction. Already I said reducing agent means it oxidized, right? Because loss of electron taken place. So you just write bromine or your Br minus or bromide loses electrons because it oxidized. Okay, in this way you can write the answer. Now question number 5. Hydrogen and iodine react together in a reversible reaction. Hydrogen iodide is formed. This is the chemical equation you can see. The forward reaction is exothermic. Gas syringe containing an equilibrium mixture of hydrogen iodine and hydrogen iodide gas was sealed and heated to 250 degrees centigrade. The equilibrium mixture was a pale purple color. Is that diagram is given. What is meant by the term equilibrium? So very simple. Equilibrium means equal conditions supposed to be equal, right? The rate of forward reaction is equal to the rate of backward reaction. Is the appropriate definition for the equilibriums. Or you may write it like the concentration of reactant and products are constant. So that also the definition of equilibrium. Now B, the plunger of the gas syringe was pressed in, and while the end of the gas syringe was blocked, this increased the pressure. Position of equilibrium did not change. So when you increase the pressure, the position of equilibrium did not change. The color of the gas mixture turned darker purple. First bit, give a reason why the position of equilibrium did not change. So in this activity, they're talking about the high pressure. Increased pressure means it meant like high pressure. High pressure. So make sure that here they're asking what is the reason the position of equilibrium did not change. The answer will be same number of mole of gas on the both side of the equilibrium. Look at this chemical reactions here. Here we have 1 mole of hydrogen, colorless gas, whereas 1 mole of iodine react to form 2 moles of hydrogen iodide. So 1 mole plus 1 mole is going to be 2 moles at the reactant side. On the other hand, I mean in the product side, there will be 2 more. I mean same number of moles in the reactant side, product side. So we know that from the Le Chatelier's principle, if at all number of moles of reactant is equal to the number of moles of products, okay, same number of moles of gases is present in the reactant and the product, then there will be no effect of the pressure. Okay, there will be not effect of the pressure. So that is why there will be, position of equilibrium did not change. So you can write that same number of gas mole on the both side of the equilibrium is same, so that there will be no changes. Second bit, just a while. Okay. Second bit is suggest why the gaseous mixture turned darker purple even though the position of the equilibrium did not change. So you'll know when you actually that means the reaction happened. That means the reaction is happened. So when you increase the pressure here, what happened in both directions? The collision rate.
নমস্কার বাচ্চারা, আমি কলকাতায় ভালো আছো? আমি ভালো আছি। So hello বাচ্চা।
So So just a while. Just a while, students. Can you hear? Okay. So is it being said to you, right? Okay, so I was talking about, okay, here they're talking about high pressure. So, yes, in fact, why the gases mixture turned darker purple, even though the position of equilibrium did not change. So the reaction is happened as here you can know the condition is in the pressure is increased. I mean, they are talking about high pressure. When you increase the pressure, what happens? In this equation about hydrogen iodide actually reacted together and form hydrogen iodide. Okay, so what is the reason? Basically, when you increase the pressure, the particles will collide faster way. Okay, collision will take in place. Okay, so that is why the particles comes closer and the color change found out. Okay, so just rewrite it, increase the pressure particle, then the molecules will come closer and the collision rate will increase. So that you just write here. When you increase the pressure, the particles collision takes place and molecule will come closer. So that is why the color, I mean the changes found out. What changes? It turns dark purple. See, okay, the temperature of gas syringe was increased to 300 degrees centigrade. What happened to the position of equilibrium when the temperature of gas syringe was increased from 250 degree to 300 degrees Celsius? Now they are giving condition for the high pressure. Why? Because high temperature, right? 250 to 300 degrees centigrade. That means temperature increase. The condition of temperature is high. Okay, increase means high. You meant. So always remember, in the high temperature, always favor the backward reactions towards the reactant side. High temperature always favor towards back side. Okay, from the right to left. That is called backward directions, backward reaction also we can see. But low temperature always favor forward reactions. Okay, from left to right. So here the temperature is increased to 50 to 300. That means what happened? Here the temperature increased so that high temperature is the condition. So high temperature means the reaction will favor towards backside. I mean towards left. Okay, so you can write here uh, the position of equilibrium towards left side or reactant side. Okay, now second bit. What is second one? What happened to the rate of reaction? Rate of forward reactions and the rate of backward reaction when temperature of the gas syringe was increased from 250 to how much? 300 degrees centigrade. So always remember it as in fact the pressure was increased before, so the collision rate is actually increased. I mean they come closer, so that here in terms of the forward reaction and backward reaction, the rate will be faster, the speed of the reaction in both direction. Why? Because the pressure was high, right? So the collision is taken place, successful collision is taken place, and the particles come closer, so that the speed will increase in both direction. Okay, so you can write rate of forward reaction will be faster or increased, and rate of backward reaction also will be increased. Okay, now question number 6. A, all sodium salt are soluble in water, all nitrates are soluble in water. Barium carbonate is insoluble in water. Describe how you make a pure dry sample of barium carbonate by precipitation. Include the name of the starting material, full practical details, the chemical equations. Make sure that this going to be a plan and investigation type of questions. Okay, so here it is clearly mentioned that you're gonna demonstrate the activity here, but here just need to write it as they mentioned about the starting materials, and then the full practical details we have to write. So they're talking about precipitation reaction. It's very simple. So how are you going to prepare the barium carbonate? So basically we have to have two salt, right? Here we have given here barium carbonate, and here we have another compounds as well. Okay, nitrate compounds also. Okay, so what we take it first, let us take the starting material is mix sodium carbonate and barium nitrate together, and let us dissolve in the water also and mix together. After mixing, what happens, that's gonna form a different solution. Okay, so after mixing, just you need to filter it out. Okay, after mixing of these two salt here, we have to filter it out. What you have to filter after mixing of sodium carbonate, barium nitrate, obviously the chemical reaction takes place and barium carbonate will produce. Okay, so that barium carbonate need to be filtered it out. So after filtrations, you have to wash the residue. Residue means here we are talking about barium carbonate. Okay, wash it properly, and after that you just go for the drying. Okay, after you washed the impurities, what we call it residue here, barium carbonate, then you have to take for drying. So dry it, that's going to be the salt. Which one? Barium carbonate. And the chemical equation, in fact, you can write here the barium nitrate when you add with the which one? Sodium carbonate, then you are going to get barium carbonate and of course sodium nitrate as well. So this is the chemical equation. Very simple, right? Now B, nitrate decompose when heated. First bit, write the chemical equation for the decomposition of sodium nitrate when it is heated. So sodium nitrate is NaNO3. When you just heat it, then it produces sodium nitrate and oxygen gas on the other hand. The second is the unbalanced chemical equation for the decomposition of hydrated copper to nitrate crystal is shown. Balance the chemical equation for the reaction. Hopefully you know this one, just need to balance the chemical equation. Okay, this is the first compound is given, right? So here we have, at the initial there are two coppers, so just you multiply here two, and the rest of the, here we have actually how many? If you count about the hydrogens and oxygens at the reactants and the product, that's supposed to be equal. So that look at the reactant side, how many hydrogens are there and how many nitrogens are there. So here nitrogen number will be 2 times of 2 is 4, so that just multiply here 4. And look at the hydrogen numbers and the reactants. So hydrogen here 2 times of 3 will be 6, 6. 6 after here you just multiply the 2, that means there's going to be a 12 number of atoms. So 6 2 times is 12, so here multiply 6, so hydrogen will be became 12. And as for the numbers of reactant production, just match up. I mean just count it. If it is equal number both side, copper, oxygen, nitrogen, hydrogen, then that's going to give you the balanced equation. Okay, third one, when the hydrated copper nitrate crystals are heated, steam is produced. When the steam condenses on the cool surface, it turns into a colorless liquid. Anhydrous copper chloride is used, so the colorless liquid contain water. How does the color of the anhydrous copper chloride change? So basically, this cobalt chloride paper we use for the test of water. Okay, cobalt chloride paper we use the test of water, and moreover we use the copper chloride as well. Okay, so here what changes do you find? How does the color of anhydrous copper sulfate? Anhydrous means actually absence of water. Okay, so when you add water, to anhydrous cobalt chloride. So it will turns the color change takes place. So basically, the changes of anhydrous cobalt chloride paper will change from blue to pink color. Okay, blue to pink color. So if there is a water, if there is a presence of water in the cobalt chloride paper, then it changes from blue to pink. Okay, this gives you the changes of the color. Now, fourth one, how would the students test the determine if the water is produced with third bit is a pure. So purity of water to be checked by means of boiling point and melting point. So if at all the water is pure, then the boiling point will be constant, same as it is 100°C. If, for example, let's say you found to be measured, the boiling point is more than 100, maybe 105 or something like that, then that's water is not going to be the pure water. There will be something impurities. Okay, so purity can be checked by means of melting point or boiling point. Clear? Okay, next one, seventh one. Many organic compounds such as alcohol, carboxylic acid, esters contain the element carbon, hydrogen, and oxygen only. A compound R has the following composition by mass: 60% of carbon, 13.33% of hydrogen, and 26.67% of oxygen. Calculate the empirical formula of R. So empirical formula I already told you in the chapter 4, I think, right? Chemical stoichiometry calculation chapter. So here, very simple. Here they mention about carbon percentage. The mass of carbon, hydrogen, oxygen is given. So right here, mass of carbon is 60. Its atomic mass is 12. And whereas hydrogen is 13.33, and then mass of hydrogen, you know, 1. Similar here, oxygen mass is already given 26.67 by the mass number. So basically, number of mole to be calculated. So you know that number of moles is in fact given mass divided by air. I mean relative atomic mass. So given mass is 60 by 12 for carbon, for hydrogen 13.33 by 1, for oxygen 26.67 by 16. So we can easily calculate the number of moles. So we got number of moles for first carbon is 5, and the number of moles for the hydrogen is 13.33, and number of moles for oxygen is 1.66. So now second step is to calculate the mole ratio. Mole ratio, how do you get it? The smallest mole to be divided with the each number of moles. The smallest mole means in between 5, among 5, 13.33 or 1.66, which is the smallest one. Of course, 1.66 the smallest mole number. Okay, this number to be divide with all of them. I mean for carbon number mole and hydrogen moles and oxygen mole. So that mole number is 5 divided by 1.6. So you got it 3, the mole ratio for carbon. And here 13.33 divided by 1.66, so 8. Then the mole number of oxygen is 1.66 divided by the same 1.66 only. So you'll get 1. So mole ratio we got it 381 for carbon, hydrogen, and oxygen. That means there will be 3 carbon atoms and hydrogen atoms, 8 for hydrogen and oxygen for. So the empirical formula going to be C3H8 and oxygen. So oxygen 1 is, if you write it's fine. If you are not writing 1 also, it's fine. It's okay. Okay. Second is about compound S has the empirical formula of C2H4O. The relative molecular mass is 88. Calculate the molecular formula of compound S. It's very simple. So already mentioned the relative molecular mass of this compound is given 88. And first and foremost, you have to find the, here empirical formula mass here. So empirical formula mass, unit of empirical formula mass going to be 44. How do you get 44? This here 2 carbon, 4 hydrogen, 1 oxygen is there. So 2 carbon is equal to 24 because 1 carbon contain 12 AMU, right? So 1 hydrogen is 1. So there are 4 hydrogens of 4. 1 oxygen is the mass of 1 oxygen 16. So just add it. So after adding, you will get 44. This is going to be the MR of the empirical unit. Okay. So now how do you get now find the MR of the empirical unit completely as it is mentioned here, the molecular mass is 88, and just now we found it the empirical mass for this compound. Okay, so here you are going to get the unit. How will you get it? By just dividing MR by the empirical mass of this compound. So 88 divided by 44, so you'll get 2. So 2 is going to be the MR of empirical unit. Okay, now after getting 2, we have to find the molecular formula. So molecular formula going to be which one? Unit into the given formula, given empirical formula. So that you will be getting here. This is the given formula. So molecular formula MF will be equal to 2 times of its empirical formula. So 2 is basically the unit what we got it after dividing 88 divided by 24. So after that, you're gonna get it C4, hydrogen 8, and oxygen 2. Okay, it's a easy type of questions. Now see, compound T and V both have the molecular formula C3H6O2. Compound T produces bubbles of carbon dioxide gas when it is added the aqueous sodium carbonate. Compound V is an ester. First bit, what is the name given to the compound? Sorry, what is the name of the name given to the compound with the same molecular formula but different structures? So in fact, we know that if there will be same molecular formula but different structure, that phenomena is well known as structural isomerism, right? So we just write it structural isomerism or isomer. Second one, draw the structure of the compound T and V. So all the atoms and all the bonds, compound T. So they are talking about compound T. So here compound T means that produces bubble of carbon dioxide. So it's supposed to be alcohol, right, when it is added sodium carbonate. And compound V is an ester. So T is basically alcohol and V is basically ester. So by using how many carbon? So there C carbon number is 3, hydrogen 6, and oxygen 2. So by using this formula, you have to make a alcohol structure. So just to draw the 3 carbon same as it is, and this is the bond structure. Hydrogen, you just attach it. Sorry, this is going to be the acid actually. It is not going to be the alcohol. Sorry. Okay. Compound T is because it produces bubble of carbon dioxide gas when it is added to the aqueous sodium carbonate. So this compound is supposed to be acid. Okay, because in acid there will be 2 oxygen, right? So that the compound T is a acid, but 3 carbon it is a which acid? It's supposed to be propanoic acid, and compound V is an ester. Right, so first draw 3 carbon over here, and then hydrogen to be attached with the carbon, and here at the last you just write the functional group of acid. So C11O and OH, so that will be the acid. Which acid? 3 carbon means propanoic acid, right? And then draw the structure for compound V. So that also this by using the same formula, 3 carbon supposed to be there, 2 oxygen and 6 hydrogen. So just to draw the carbon here, 1 carbon, 2. Okay, then hydrogen to be attached at the middle, because V is actually ester, so we have to show ester link. So ester functional group basically C11O and here O. So that C11O and O, and at the last there will be another carbon with a hydrogen bonded. Okay, so finally it's going to be like this. Okay, this is a example of ester. Now third one, all compounds with the molecular formula C3H6O2 can undergo complete combustion in an excess of oxygen. Complete the following chemical equation for this reaction. So here, this is the chemical equations. Okay, when you actually burn in presence of oxygen, always produces carbon dioxide and water. So as per the atoms needed here, just we need to balance it. Okay, so balance it both sides that it's going to be equal. So don't keep it like a skeletal equations. Multiply the number in front of the element, each element, to make it balance both sides. Okay, reactant side and product side. So it's going to be the balanced chemical equation then. Okay, so always while you're writing the equations, so make sure that you're going to write the balanced chemical equations. Okay, so D compound W has the molecular formula C2H6O. Compound W react with the heated with the ethanoic acid and catalyst to produce sweet smelling liquids. Okay, they are talking about alcohol. Why? Because they are saying compound W has the molecular formula this. Okay, alcohol one oxygen. Okay, and moreover, it's clearly saying that W react with ethanoic acid and it produces sweet smelling substance. That means ester. So in the esterification reaction, we know acid and alcohol to be reacted to form a sweet smelling compounds that we called it ester, right? So give the name of the homologous series which compound W belongs to. So compound W belongs to alcohol or H. Okay. Second, draw the structure of W, show all the atoms and all the bonds. So as it's going to be alcohol, ethanol, so just draw like this. Okay, here one carbon, here one carbon, hydrogen just to be attached. Okay, here and alcohol group you attached over here. So this will be the structure. Already I have done before. So just look at it. Okay, this is going to be the structure for ethanol. Now, alkanes and alkenes are hydrocarbon. First bit, what is the meant by the term hydrocarbon? So you know that hydrocarbon is a substance contain a compound contain hydrogen as well as carbon. Very simple. So right, they contain hydrogen and carbon only. These are known as hydrocarbon. Second bit, straight general formula of alkene. So it's the general formula of alkane and alkene. So alkanes are saturated hydrocarbons, single bond compound. The formula CnH2n plus 2, whereas alkene formula will be CnH2n, n for number of carbon atom. So next is F. Ethanol can be produced from the long chain alkane as shown. So long chain alkane, first step will form ethene, and the ethene will be again in the second step it's producing ethanol. Okay, that means from the alkane to until you get ethanol, you have to do what are the chemical reaction to be taken place. Describe two-stage manufacture of ethanol from the long chain alkane contain octane. Octane means C8H18. Include the name of the type of chemical reaction that occur, reaction equation you have to write, and reaction condition to be written. So make sure that first write the type of, I mean the name of the chemical equation happen in the step one. The step one, what would happen? One long chain of alkane actually cracked under heat, so it produces ethane, right? So example, this first step, the name of the reaction is cracking. Here we have taken octane. So octane is heated, then it form alkane. Okay, it form alkene and lower alkane as well. So that it's basically cracking reaction. For this reaction, we need to have about 400 degrees Celsius temperature. Pressure is supposed to be 7 atm atmospheric pressure, and the catalyst is supposed to be aluminum oxide. Okay, this is the condition required for this cracking process to be taken place, where the bigger alkane will be now converted into alkene as well as alkane too. This is called cracking. The second step, what happens, the second step, the reaction name is called hydration. Hydration means addition of water. Hydration is adding water. So when this alkene you got it from the first step, that alkene to be added with the water, so that uh, the compound is going to form is ethanol. Okay, for the reaction to be carried out, we must have conditions, that conditions to be satisfied. So what are the conditions needed for this chemical reaction to be taken place? So basically, the temperature should be taken 300 degrees centigrade, whereas the pressure to be taken about 60 atm. And in fact, the catalyst to be used is phosphoric acid catalyst to be used as 3PO4. So that we will be getting ethanol. Okay, so in this way you can write it down. I think that's all for this paper. So thank you for your attention.